So welcome students. In this question you're given that you have a line x plus 1 by 1 is equal to y minus 1 by 2 is equal to z minus 2 by 2. And you have a plane 2x minus y plus root lambda z plus 4 is equal to 0. If theta is the angle between these two, sin theta is given as 1 by 3. What is the value of lambda? So you have a plane and you have a line. So let theta be the angle between the line and the plane. Now sin theta is given as 1 by 3. If that is so, lambda is equal to what? Now what's the direction of this line? The drs of this line are 1, 2 and 2. And what are the drs of the normal to this plane? The normal to this plane has drs 2 minus 1 and root lambda. Now as you can see, if this angle is theta, this angle is 90 minus theta. Now you have two vectors whose directions are known and the angle between them is 90 minus theta. So cos of 90 minus theta is nothing but the dot product of these two vectors by magnitudes. It is 2 minus 2 plus 2 root lambda divided by the magnitude of this vector is 3, root of 2 square plus 2 square plus 1 square, into root of 2 square plus 1 square plus lambda, that is 4 plus 1 plus lambda. This implies cos 90 minus theta is nothing but sin theta, which is given as 1 by 3. So 1 by 3 is equal to, these two gets cancelled, 2 root lambda by 3 root 5 plus lambda. So 3 and 3 gets cancelled. This implies 5 plus lambda is equal to, if you square it on both sides, 4 lambda. This implies 5 is equal to 3 lambda. So lambda is equal to 5 by 3. So this is the value of lambda required. Thank you.